all for coming. My name is James Alexander. We'll be talking data visualization with Bokeh, or Bok, or however you want to pronounce it. Who has in the room never used Bokeh, never heard of it, never used it? This talk is for you. This is a beginner level session. Who is an advanced user or someone that's used Bokeh a lot? I want you to keep an eye on me, make sure I don't do anything silly, and correct my mistakes. I've got Bokeh loaded into, can everyone see this okay? Is it too small in the back? Read it okay? This is a collaboratory notebook. Has anyone never heard of collaboratory? Google's Colab. So everyone has heard of collaboratory, great. Jupyter notebook inside of Google Docs, essentially. So what this is allowing me to do is run my Jupyter notebook in the cloud, and this link here, this bit.ly PyData Bokeh, is a link that you all can use right now to access this exact same notebook. And so you can get it in read-only mode and see changes as I make them, or you can use it to sign in with your Google account and copy and paste and use it and run it yourself, and modify the code and play with the exact same code that I'm using here. All of my code is in my GitHub repository. It's all pushed up as of this morning, and I'm going to use some sample apps from the Bokeh repository here a little bit later on as well. So those are the links that I'll show again later on, but if you want to follow along, they're all in the notebook. Some about me. I work for Leaf Software Solutions. I spent 10 years as a C#.NET developer. In the past year, I've been doing Django web development, so I'm coming at this from a very much web developer technology focus. So not as much as a data science practitioner, but more web development. I want to do basic plotting and styling, going through a lot of the basics of how Bokeh is going to work, and linking grids together, embedding it into a Django app, since I've been doing Django development, running Bokeh server, which we already saw this morning. Calvin kind of stole my thunder a little bit at the end of my climax of my talk, but I have other examples too that we can show. We should have exchanged notes beforehand. And I put in my abstract that we can do all this without JavaScript, but I do have an example, if anyone is interested, of what this looks like using custom JavaScript for eventing inside of the browser. So if we're not completely allergic to JavaScript, I can show some of that if I have time allowing and so forth as we go forward. So the first thing I want to do as I'm loading this up here is do some basic imports, and down here do a data download of sample data. So as we all know, Colab is running on a virtual machine on Google servers, and so I need to set up my environment, get the sample data downloaded so that I can reference everything from the Colab notebook. Another thing we have to do to get Bokeh to output to my Jupyter notebook is to run this output notebook function as part of the Bokeh IO. I've kind of shimmed it because for every single cell, you get a different iframe in Colab. And so every single cell has to also run output notebook. And so I didn't want to have to change all my code, and I wrote it in Jupyter notebook. I just shimmed it and said, OK, call output notebook and then call Bokeh show instead of having to do output notebook on every single slide. So my first example is, a lot of these are straight out of the tutorial, but here are some basic XY plots and just two lists, an X and a Y. And my first scatter plot, 3 lines of code. Create a figure, give it a height. And let's not put our radius in here first. Let's just show what it looks like with my X and Y lists and show our results. So I realize that the dots are probably not visible, but what I want to point out here is that with 3 lines of code, we now have a graph that we can pan and zoom, and I've got, I can zoom in and out with my scroll wheel. If I wanted to get to a certain point of the graph where I've got all my data points visible, it's kind of hard to see with my zoom level, but we've got X and Y coordinates here. If I hit save, or this floppy icon that is no longer using floppies these days, but you can't see my download, but it actually created a ping download. And so now I just downloaded, and I opened up in preview here a ping image of the graph that was rendered at that zoom level at that particular point. So let's do some more interesting things with it. Let's make our points a little bit bigger first off. So size will give you the number of pixels of diameter you want your circles to be. So as I zoom out, my Bokeh, if I can zoom in with this, the circles stay the same size. If I wanted to do something like radius 0.4, the radius here is relative to the scale of my x-coordinate. So the circle will scale based on the scale of the current zoom level of the graph. So as I zoom out here now, the circles will stay the same relative size, and they'll get smaller and smaller relative to my x-axis. Another important concept to know about sizing is that sizes can be vectorized. In other words, I can pass a list of sizes to it. So if I say size, I say 20, 40, 80, and 60. And the number of sizes has to match the number of points that I'm trying to graph. So now each dot has its own size. So this, I think, would be really useful for trying to add weights to certain importance of data points, like we saw in the opening talk, that certain bubbles are larger than others. Okay, let's move beyond that, and let's add a little bit of flair to our graph. So instead of having a fixed width, let's have the width scale to however large my browser is. Let's change the title, some of the outlining of the grid, of the graph itself. And instead of circles, let's do squares. Make them kind of a reddish color, and give the renderer output of our square. And let's change the glyphs, some properties of the glyphs. So we're going to have kind of a nice, a lot different graph. It's got some character to it, right? It's probably not as much as you want for a professional presentation like this, or if you're doing something for work. But it's good to know you have these types of options. I love that we can import pie, and it's the mathematical term here, not the food. But if we want to do something even a little bit fancier, if we say we have dates for our x-axis, something over time, for example. Give me a list of dates here instead of my x-coordinates. And now let's change our axis again. Let's change the line to be red. Let's change the font size so we can read it. And let's change the orientation to pi over 3 radians. So what this is going to do, instead of having labels that are straight up and down, they're going to be slightly skewed. So if you've got a lot of data that's scrunched together, you can fit them all onto the same axis. And you can also just do vertical if you want them just all be 90 degrees rotated. The minor tick in and out specifies that the small ticks are going to come just off the label a little bit. And so now you can see my dates are skewed. And if you had a lot of data that was scrunched together, you could style it such that you could see still everything all in one. Another notable thing here is that I've turned off all of the tools. So all the tools on the left side for scrolling and zooming are no longer visible. You just got the link for the Bokeh help. If you want to do something where you want to point out specific points, and you want to select them, you can enter a selection color and change the mode of the glyph based on whether or not it's selected. So I'm going to change the alpha channel, and alpha channel is basically how visible is it. So an alpha channel of 1 means it's completely opaque and you can't see through it. So an alpha channel of 0.1 means that you need 10 of them overlapping in order for it to no longer be visible all the way to the bottom of the graph. And so here now we've got the same points, but as I click inside of them, I can say, let's point to this dot or to this dot. And if I want to click multiples, I can hold shift and click multiples. I mentioned a gotcha here is that I think that I haven't fully investigated as to why this happens, but I think it has to do with sizing using number of pixels and radius having to calculate how wide a pixel, or how wide the dot is based on the diameter of the graph, such that now if I try to click on the edges of this circle, it no longer, except for that case, actually registers the click of the dot. But it's more consistent if I click closer to the coordinates of the XY. So I think it has to do with pixels versus radius relative to the graph. So far I've only seen squares and circles for glyphs, but you can do any types of glyphs here that are on this list. So if you've got lots of series you wanted to superimpose on the same graph, you can use multiple different types of glyphs for X's and whatnot to distinguish your data. Anyone that's done Windows Forms development, probably not many of you since it's a Python conference, but I did. There's something known as a binding source. And what it is a level of abstraction between a SQL query or a CSV file. You stick it all into a binding source, and then you can bind that binding source to a grid or a list or something else. A column data source works kind of the same way, where you can take your set of data, stick it all into a column data source, and then you can reference that on one or more glyphs and graphs, and they all are now linked by that common data source. So if the underlying data changes in your data source, the graphs are all going to change analogously to whatever change the data source applied with it. So let's give it my x and y, and let's add some labels to it. Similarly to how I vectorized sizes, I'm vectorizing descriptions. And let's add some tooltips. So now kind of hover over my dots, let's display on the left side the label of what I'm going to display, and this dollar of the index. So 0, 1, 2 as the list goes through forth, and the x and y values. You can add format strings here, and we'll see how that works in just a little bit. And then for our circle, we add our source that came from our data source. So as I hover over, you can see, maybe depending on the size of the font, that my x shows up, and the x has a lot more precision than the y coordinate does. And so it kind of depends on what you want to show. Like, do you want to show the range of how wide your x is, or do you want to show just that data point? So if you wanted to show just the integer value, you apply a format string of only give me integers, or you can say give me 1 decimal point if you said 0.0, for example. And so now you get 1 decimal point there instead. So let's do something a little more fancy. Let's pull in some of that sample data that I downloaded earlier. And this is a glucose graph. I'm pulling out specifically your glucose level over a day. Not yours, but the sample data for October 6, 2010. Let's see, we've seen a lot of this before. Let's make a line graph over my x and y that I'm coming out of my glucose graph. And let's superimpose that with circles on the exact same data. So I'm not using a column data source, but using the exact same x and y's. And we're doing something a little fancy here with our circle to say, make the circles mostly transparent, except if we're hovering over them. And then if we're hovering over them, let's make them kind of that reddish color again. Again, let's return our renderer, pass it into this hover tool that we're getting out of models, and set a hover mode of hline. So horizontal line means that wherever my mouse is, I want a horizontal line coming out from that point to be quoted as hover. And so we get this kind of fancy hovering effect where everything along where my horizontal line is from my mouse is now visible, all because we're superimposing the same data over the line. The previous one was mode of mouse. In that case, where exactly where the mouse is the hover mode. And we could do kind of a similar thing with a vertical line to where vertically left and right, wherever my mouse is, I can now hover over and have kind of a similar graph with the stock prices of Apple. This is what this is from the sample data. The main distinctions here, again, setting a V-line. And we can also show here that we can vectorize how the data is formatted as part of our tooltips as well. So we specify date, close, and volume, so the actual date value that's coming out of it. We have to do something fancy here too, that we're converting NumPy, we're using NumPy's DateTime converter just to convert strings into dates. And I'm purposefully adding a space so that I can show this as an example, adding a space to the column name so that when we're formatting our adjusted close value, you specify an add curly bracket to specify the field name so that it still escapes to the same field rather than having to worry about spaces in your fields. Like I said with the formatters, you can specify just a DateTime format, so you get %f for the date, %2f for the like printf style formatting. Otherwise, use Python's built-in formatting. Okay, so let's move on to annotations. So instead of, for example, always selecting on circles if you want to annotate, if you wanted to point at things, you can draw arrows specifically on your graphs. So I've imported more arrows than I'm actually going to use here, but I'm importing them as an example. So you have open arrowheads, you have just lines, you can have a full triangle. A lot of this is the same from the previous graph. The distinctions are I'm adding now a layout for my arrowhead. And in order to specify where the arrow is going to appear on your graph, you have to give it XY coordinates. And since my x-axis is date times, I have to give my x start and end date as DateTime formats. And so I'm just converting these strings into dates. so that it can appear on the graph as I want to. In addition, we can specify boxes. So if you want to have regions of, above this threshold or below that threshold, or some kind of box contained entirely within a section, it's a little bit weird that you say the upper box has a bottom. But again, if you've ever done Windows Forms development, if you're anchoring a section, you anchor the one thing that you want to specify here, and then everything else will fill in as much as it can. And it works very similar in Bokeh. So I can do the same thing with a lower, so a box is going to appear at the bottom, draw it starting at 200, fill into the bottom, and let's give it 4 coordinates for a box that's going to be completely contained within our graph. So that same Apple stock price, we now have our arrow, we have some boxes, and if I zoom out, you'll see that the graph doesn't change, but my boxes fill in the completely variable area. Instead of just squares, you can add whatever other geometry you want to, or you can just specify points that'll be filled in, and it'll create whatever geometric shape you have based on the points that you specify as part of your vector list. I mentioned a couple of times that column data sources can be used to link graphs together. You can also do it just by specifying the range of the second graph is equal to the range of the first graph. So here, we're doing a lot of the same things. We're using slightly different data. Just give me an XY, either add 10 or give me an absolute value -5. Let's use some common options we're going to use on all of these. Let's create a circle, a triangle, and a square graph. But the interesting point here is now the second graph is using the first graph's X and Y range. The third graph is only going to use the X range. So what we're going to see with this is that now as I move the first graph, the second graph and the third graph are going to move horizontally. But if I move it vertically, only the first 2 graphs are going to change, since those are the only ones that are linked with their X and Y ranges. You can do the same thing with selections. And this one has one of my favorite, I think, tools that comes with Bokeh, a lasso selector. So there's hours and hours of fun that I've spent just lasso selecting. Oh, and it's not even going to work today. Why isn't it going to work today? Select, box select. Man, that's what happens when I do too many lasso selects. It's really not going to select for me, huh? Well, you get the idea. The idea is that, oh, here we go. So, I always come back, and then I can circle back, and now I get partial regions that are selected, not selected. It's like I said, hours and hours of fun here. Anyway, that's the idea. So whatever selected range is linked between the 2 graphs. Bar charts, I'll kind of move through these. I've got some videos at the end that I want to show that are, I think, frankly, more interesting than the bar charts. There's also the first example of a legend. You can specify, the colors of each of the things that you want to appear here. Stack bar charts, if you wanted to have something horizontally that's grouping data based on a common theme. Grouping, so if you have groups of data, they're all going to be columns, and they're all going to be sectionalized. We're doing some kind of funkiness here with sum and zip and all these things, but you're essentially creating a list of tuples of fruits and years. Throw them onto a data source, and let's create a factor range here. And the interesting part is this factor C map. So we want to apply colors to a given year, but each fruit is going to have a different value for that year, and we're going to group by fruits. So here we're specifying the 3 colors of the years we want to colorize, and it's a little bit weird that our start and end are the index of the interior tuple. So that took me a while to realize that that's what they're talking about with the start and end of our factor C map. And so what it produces here is kind of this fancy graph that's grouped by fruit and has years for each of them, colorized by a common year. Let's move on to some GitHub data. Again, coming from the sample data, our data looks like we have date times, days of the week, and the time it was committed. So we want to see how many commits occur at a certain point during the day. So the first version we could do of this with a circle bar chart is that we just see a bunch of commits throughout the day plotted, kind of superimposed on each other, which is fine if you want to do that. But something else we could do with this is if we wanted to vary where the vertical axis is on each plot, we can space them out a little bit so that now we can see kind of a hover cloud of where important values are for our commits throughout the day. So that Thursday morning is a little bit more popular than Saturday and Sunday morning, for example. Okay, Datashader. This does not work in the Colab notebook, so I apologize. It relies on a persistent connection to a server. So I've got it running here, very much Julia Child's. Like I baked this one the night before. So if I can zoom in so we can see this. There we go. Let me get my data in here. So this is kind of a long preamble of give me sets of 10,000 data points randomly distributed along a normal curve that have categories and colors. So it's one of the more complicated dictionary comprehensions that I've ever seen, but it's effectively we're creating just a table of values. So if we load the entire thing into a Bokeh notebook like we do with everything else, it works, and you can render it. But as I'm clicking and dragging and moving around here, I don't know how much that shows up. It's really, really sluggish, and it's only 50,000 data points. I think most of us have way more data than 50,000 data points. It gets even worse as I try to zoom in or out, and so there's got to be a better way. And that's what Datashader does for us, that it allows us to render just a portion of the data that we're actually viewing at that point. So in a similar fashion to everything else, output notebook, we draw a figure, but now we have this callback function. So given an x and a y range and our parameters of the graph, create a canvas that we're going to draw on and aggregate based on some function. In this case, I'm just going to count by that category and group them all together. This Datashader call is what will actually do the rendering. There's a threshold value here, too, that you can use to vary how much the overlapping data is going to be shown. And I can play with that a little bit and see varying values. So now our graph is very responsive. We can zoom in and out, and it works a lot better. This is, I think, the closest I've ever come to actually having the CSI enhance mode. So if I zoom in, I get enhance, I zoom in, I enhance, zoom in. But if I change the threshold value, for example, and I say 1, it looks very similar to what we had before, where everything is displayed, where you get a rendering of more of the data rather than kind of the sampling size of it. But it's still responsive because it's only rendering just what it has to in an aggregate. I think I had 10 minutes to go. 5 now, okay. Let's do some quick JavaScript. I can show you that real quickly here. So along with all the other graphs, the distinction here is now we can add custom JavaScript and affect the graph on a change of some kind of form element. So if I change my selection criteria here, the graph will change based on whatever I've picked. If you've not done much web development, debugging this is going to be really complicated because it's in a string that's in a Python thing that's rendered, but you can do fancy things like console.log. And assuming I've got my dev tools open, maybe a whole lot of things that are coming through here. Rerun it because I have to put the code back in there. So now every time my selection box is going to change, I now see my hello world. You probably can't read, but it showed up twice there. Okay, let's move over to some more interesting use cases, at least for me as a web developer. Let's run over to my Django project. Let's do this one. So instead of doing output notebook like we've done the whole talk so far, we're going to change to importing this embed function for components. A lot of this is going to be very, very similar. I'm pulling data out of a local SQLite database. I've got a download link in the Django project. It's on S3 if you want to download this and pull it out. But essentially, I'm going to create a list of graphs that I want to render all at once on a single page. And for fun, I decided I wanted to link all the XY ranges together. And so when we look at that, and I pull up this guy. This is the fantasy football as determined by Yahoo for Jamal Charles through the past 7 years. He had an amazing week 15 in 2013 for 52 points for a single player, which is, I can't even imagine. And with all this data, I analyzed and was going toward the absolute best fantasy football team, which I'm proud to say that I have 2-3 record this season so far. So it was almost a complete waste of time to do this much data analysis on my fantasy football team. But I learned a lot about the scraping from the huddle.com. If you're ever curious, I've got the code in there for that too. Let's move on to some more interesting things with running a Bokeh server. So that was all running Django, and Django is a WSGI platform, Web Server Gateway Interface. So you get an HTTP request and a post back, and that's all you get. You don't get a persistent connection that we get with a live view of data updating in real time, like we saw with Calvin's demo. If we do want to see that, we need to actually run a Bokeh server. So I've got a script here with several that are more interesting graphs, and this is actually running a Tornado server that runs here on my machine, but you could run this, in a server environment to, I don't know how much it'll scale. It is Tornado, so it can do multiple threads, but I don't know how much load I would want to put on this. But as examples, we can plot multiple things, and we could change the underlying data source in real time from our browser. If we go to the next one, this is where we're changing pivot values. And so we could start graphing different series. So instead of just changing the values of the graphs, I can change what I'm graphing as well. I could explode by different things. I could change the grouping. I get additional charts based on what I selected. If I wanted to download all of my data here, I could just use Bokeh to export it all. And the distinction in how that's run from the Django is I use curdoc from Bokeh.io, and everything else is the same, basically. There's a lot of code for rendering and all that, but you just say add root of whatever layout you specify. So either your column, your grid, or just your figures that you throw into the layout. Moving on to the next one. This one, my lasso select again. Let's have some fun. And now let's select my dots, but also the bars on the left and the right. So these are link selections, kind of similar, but I thought it was a fancy example, and I liked it. And I'm going to run out of time showing these last few, so I apologize. This one's a fancy graph of a Fourier animation transform. You get to see circles being rendered and the line graph as it applies left and right here. If you ever want to get fancy and dig into the network, you can watch that it's actually creating a WebSocket protocol. And so this is data flying back and forth between the client and server as it's changing what is being displayed. This is the Gapminder that Calvin showed us. If you haven't seen this Hans Rosling talk, it's really cool. And I don't have any more time to show it here, but that's the same graph rendering that you can play that he did using custom software. You can do the same thing with Bokeh today. This one is kind of a simulation of reading PyAudio, of reading an audio file that's graphed from Bokeh. I don't have PyAudio installed here, so this is all just random data. But here again, you can change the graphs as they're displayed, increase the gain, and you would get different effects on your audio graphs. The last one is you can install plugins into Bokeh, and this one is a Viz.js graph 3D. And so now you get a 3D rendering that's updated live real time, and you also get moving of the graph where you can shift it around in 3D. And so that's my talk. There are the links again. I blogged about it. It's all on jamesralexander.com if the links are too hard to find. That's my time.